Good day, grade 10s. How are you guys doing? Welcome to this physics lesson. This is a physics lesson. We are looking at the concept energy. Today we're going to be looking at the concept energy, starting off with potential energy. We'll go on to look at kinetic energy in later lessons. But you'll find that at this level now, we already know how to define the term energy, from grade 8 and 9. We were given a definition. It's not necessarily a definition to say this is energy, but energy describes an ability to do something, right? The ability of someone to act, the capacity of something, a person, an animal, a physical system to do work. So whenever you used to hear the question say, what is energy? And people would say energy is something which can neither be created nor destroyed. Because energy is basically the life force of everything that is going on this planet. There is energy, and it's constantly changing from one form to another. Hence the difficulty in putting what you would term an actual definition to it. But for school's sake and for exam's sake, we have here different ways in which the term energy can be defined. Refers to the potential ability to perform work. Then those are just now effectively definitions of different forms of energy. So we gave, if you recall from grade 8, we did presentations, maybe not with you guys, but I remember with grade 8 we did presentations on kinetic energy, geothermal energy, water energy. These are forms of energy that I am sure you know. If you don't know them, if you don't know these forms of energy, if you don't know what electric energy is, and this is the first time you are hearing about this thing called electricity, then you can just pause the video for a minute or two and just rehash, go back to your grade 9 notes, go back to your grade 8 notes, and just try and recall to say what exactly is potential energy. Right, so having indicated the different forms in which energy exists, we also know that the units for energy is measured in joules. Energy is measured in joules. Others call them joules? Joules? Or are they joules? Not joules like your jaw, but joules, kilojoules. If it's MJ, it's not Michael Jackson, it's megajoules. J here, that's gigajoules. Just showing you the quantity to say it's just growing bigger and bigger. The law of conservation of energy is a law which I would hope that you get to know, not just from the definition that we give here to say energy cannot be made nor can it be created, cannot be made or created, cannot be destroyed, but can only be converted from one form to another. That is basically the entire world in this definition. This is exactly what is happening every single day. We have energy moving from one form to another, from form through form, into form, back into form. It's a very complex but exciting concept once you get to understand it. We always put this thing at the bottom of the page, say imagination creates reality, because imagination basically is energy. Your thoughts are energy, and they are in the form of a thought pattern. But whenever you think of something, it then comes out in reality. That's how energy would have actually changed from your thought to being a reality. You think, okay, I can't wait to go back to school. This holiday has been so long. It's been so long. We want to go back to school. Others were just saying, we want to drink our alcohol again. And all those thoughts then materialize into form, and then you can see them. But that's just energy as well. Someone thinks, let me make a chair, let me build a house. Whenever you think, let me build something, that's a thought, right? It's an idea. And then the idea changes into a physical reality. That's what the whole concept of imagination, creating reality, is. So today we are looking at potential energy, PE. Gravitational potential energy is just another form of potential energy. You already know these forms of energy, and at this level now, what I'm mostly concerned with in this video is to show you this formula for potential energy. PE is equals to mgh, where m represents the mass of a body. You always be given the mass of a given body, or you'll be asked to determine it. G represents gravitational field strength. And gravitational field strength on this planet, I hope you know what the force of gravity or the gravitational pull is on this planet. The gravitational pull here on Earth, we usually take it as 9.8 meters per second squared or 10 meters per second squared, just to simplify calculations. And then h stands for height. H stands for height at which a given body is raised. So what I did is, there's all these questions, there are 5 questions. What I did is I left this question out, question number 3. This is the question that I'm going to use to try and help you guys understand how we use the formula of potential energy in real calculations or in physics calculations. So we are given a question. Let me just pause a bit so that I can catch my breath. Okay, so let me just go back a bit. We got all these questions. You guys will either do these questions in the lesson when we're together, or you do them as an exercise. But what will be important is, in all the cases, to always identify what it is you're looking for. Let's look at question number 1. We're not going to do it. I'm just going to use it as an example also. A body of mass 80 kgs was hanged 10 meters above the ground. Calculate its potential energy. You know that potential energy is equals to mass, which is given here as 80 kgs, multiplied by g, which is a constant. That's the good thing. Gravity is the constant. The constant, what is that constant? 10 meters per second squared. So you have your g. So you have 80 kgs multiplied by 10 meters per second squared. What is your height? 10 meters. If you do that calculation, it's going to give you the potential energy of this body. And observe that because it's hanging from a 10 meter height, right? It's not falling, it's not moving, we are just saying it's hanging. And if it's hanging, it means that it wants to come to the ground. If something is in the air, right, it's always going to be pulled down by the force of gravity. So it's always defying that force of gravity. Therefore, it has potential energy that is stored in its system just because it's above the Earth's surface. I hope you understand this simple concept. A pendulum was made to swing. This is now number 3, the one that we're going to do together. A pendulum, please have a pen and a paper and follow this thing step by step. Write the calculation. Do cancel out when I say please cancel out. Do everything. Right? I would have been writing and doing whatever if my software allowed me to, but it doesn't. It doesn't. I don't have those little stylus pens. I don't have them. Right? Probably will have them soon. So a pendulum was made to swing, and its bob passed. It's a pendulum bob. You know that little ball that you put on a pendulum? Google it. A pendulum was made to swing, and its bob passed a point where its potential energy, PE, is equal to its kinetic energy. Potential energy and kinetic energy are equal. That's the equation that you see here. PE is equal to KE. PE is equal to KE. The speed with which the bob passed the point is 5 meters per second. Speed. Not acceleration, but speed. Remember what speed is? Distance covered over time taken, distance in meters, time in seconds, formula meters per second. So what you need to calculate here, you want to calculate how high the point is. So you are calculating height. So sometimes you will not be calculating the potential energy per se, but you will know that from a formula PE is equals to mgh. And what you're looking for is the h, right? But observe also, so now I think I just took this question because I also wanted to bring in this aspect of kinetic energy. Kinetic energy is the energy that is possessed by any object that is moving, right? Any moving object has kinetic energy. And the formula for kinetic energy is half mv squared, half mass times velocity squared. I think I was now thinking of E is equals to mc squared, that energy thing for Einstein. Kinetic energy, half mv squared, Ke equal to half mv squared. So we are told that when the bob passed a certain point, right? Don't worry if this point is in Oshakati or it's in Ongwediva or it's on the pendulum or it's in the sky. Don't worry. It passed a certain point, and at this point, the PE, potential energy, was equal to the KE, the kinetic energy. So what we do here, then on the second step, you'll find that we then take the formula of potential energy. Physics is done as an abstract concept. You must be able to solve things in the air. Solve them in the air. You can only solve something in the air first before you solve it on the ground. I don't know if you understand, but you have to be able to solve abstract calculations and then place them into the physical. So mgh is equals to half mv squared. Now what happens, because m here, we say m is appearing on both sides, so it's cancelled out. Apologies for the spelling of cancelled. There is no cancelled that looks like that. That's cancelled. That's cancelled. It's C-A-N-C-E-L-L-E-D. Cancelled. Yeah. So m, because m is appearing on both sides of the equation, it means that you can cancel it out. Yeah? Done those factorization things. I think you were doing. I don't know if there is any similarity there. You have to love your mathematics if you're going to be doing physics. If you're doing physics, you're going to have to fall in love with your math. Just go to your math subject and say, math, I love you, because if I don't love you, physics is going to hate me. And then if physics hates you, I don't know what you're doing here. So m cancels out. Now, what are you left with? You are writing this equation. Don't just look at the screen and just say, I'm understanding it. Write it. Follow it step by step. Cancel out the m. I've cancelled out my m. Right. So now you're left with gh is equals to 1 over 2 v squared, because the m is gone. 1 over 2 v squared. Right? But that 1 over 2 half v squared. Half v squared can also be written as v squared over 2. It means the exact same thing. It's the exact same thing. Half v squared is equal to v squared over 2. Yeah? Do you understand? If you don't understand, please write it and then, go back or ask me in the lesson why it's like that. So now we are at this point where gh, which remember g is gravity, h is the height, v is the velocity. Let's not forget that, right? Let's remember where we're getting these things from. G is the gravity, h is the height, v is the velocity. G is the acceleration. Acceleration, yes. So if gh is equals to v squared over 2, what are we going to do? Because now what we are looking for is h. We are not looking for G, we are looking for H. So we're going to cancel G on both sides. So we divide both sides by G. So we divide both sides by G, and then now you have V squared over 2 divided by G. This side G is cancelled out. Because, please write on your paper, V squared over 2 over G. Because G is almost like a third, you call this what? You call this a numerator, a denominator, and this one seems as if it's a denominator. I don't know what that is, right? But because the G is almost on the third level going down, it means it can actually come and multiply the 2. So that's the same thing as saying V squared over 2G. So it's actually now saying H is equal to V squared over 2G, because the G came and multiplied the 2. Now you are replacing on the right side of the equation. You can now start replacing these letters using actual values. Using actual values. Because you don't want to just start by calculating with values before you get to this point, right? Because you're going to include values, some of them are not going to match up, and it's just going to confuse you. So the V squared, remember, velocity here was 5 meters per second. So V squared is 5 meters per second, in brackets, squared, divided by 2 multiplied by, what is the value of gravity? 10 meters per second squared. 2 times 10 meters per second squared. So if you solve that, the square that's on 5 meters per second squared squares everything that's inside. So it's 5m squared, that's 25m squared, per s squared, or s times the square, gain s squared, divided by, here there is no square that's outside of the bracket, so it's just 2 times 10, which is 20 meters per second squared. 20 meters per second squared. Now when you're dividing, when you're solving, observe, there is an s squared on the denominator and an s squared on the numerator, so they cancel out, they are gone. On your denominator, on your numerator, which one is on the top, by the way? The numerator is the one that's on the top, yes? So on your numerator you have m squared, but on your denominator you have m. So the m goes, it cancels out because m squared is just like 2m's, yeah? M times m. So it goes and you cancel out the square. So now you are left with 25m, 25 meters, divided by 20. And what do you get? You get 1,25 meters. That's how you get to that particular answer, right? So that's the lesson. That's the whole lesson, right? This calculation is what is important. So you'll find also with kinetic energy that it will mostly be on calculations. So I probably won't do a video for kinetic energy because all you need is to know the formula and how to apply the formula. So guys, please play the video again and again and again, go over the calculation, and then we can then do these calculations for 1, 2, 4, and 5. Maybe we'll do the ones which you would think are difficult, and then the other ones you can do them as your exercise. So thank you very much, guys, for taking part in the lesson and watching the lesson and paying attention and doing all that other stuff. Thank you very much. Goodbye.